Okay, so I want you to close your eyes for a second. Just settle in with me. Imagine a scene, something completely, utterly impossible, but it's rendered with such perfection that your brain just accepts it. It feels totally, flawlessly real.
Oh, here we go. We're starting with a trip down the sensory rabbit hole again, aren't we?
We absolutely are. It's the only way to do this justice.
All right. All right. I'm game. Let's hear it.
So imagine you are running like a full-out sprint across the surface of the moon.
Okay.
It's silent, it's alien, it's vast, and that low gravity, it just feels exhilarating. The gray dust is kicking up behind you in those famous slow-motion wrister tails.
Got it. The classic Apollo footage vibe.
Exactly. But here's where the cognitive dissonance kicks in. You look down and you're not in a spacesuit. You're wearing your oldest, most comfortable college sweatshirt.
Wait, like my actual sweatshirt, the one with the faded logo.
The very one. And get this, you're also wearing those ridiculous fuzzy slippers you secretly adore.
Oh, man. Not the slippers.
Yes, the slippers. And they look absolutely perfect. You can see, like, the tiny worn patch on the heel. The detail is insane.
Okay, this has gone from space exploration to a very specific and highly funded fever dream. But I can picture the slippers perfectly, so what happens next?
Exactly. That's the point. It's hyper-detailed. The lighting is totally cinematic, but the whole context is just pure absurdity. And then suddenly you hear it.
Hear what?
It's not some generic narrator. It's not a stock voice actor. You hear your voice.
My voice.
Your voice. Perfectly calibrated, the pitch, the intonation, it's flawless. And it's delivering that one iconic line from your favorite sci-fi movie. Maybe it's, "I'm afraid I can't do that, Dave," or, "May the force be with you."
Wow.
It's hyper-realistic, impossibly detailed, and here is the absolute kicker. This entire 30-second high-fidelity, personalized movie, it was generated in under a minute flat.
Wait, what? No. No way.
Yes.
When you combine that level of perfect physics, perfect lighting, and my actual voice and likeness, we're not just talking about deepfakes anymore. This is like a deepfake that hired Spielberg to direct it.
And then cast you as the star.
Exactly.
Yeah.
That sounds wild.
Yeah.
It sounds exhilarating, but I've got to be honest, the fidelity you're describing, it makes my skin crawl a little bit.
Oh.
It's too real.
And that uneasy feeling, that's the bullseye of today's deep dive. Okay, let's unpack this. What you just experienced,
Yeah.
that is the core idea behind Sora 2.
Sora 2.
Okay. This is the newest video generation tool from OpenAI. The same people who brought us ChatGPT, but. And this is a huge but. We need to be crystal clear that this is not just another little step forward for text to video. This is a tectonic shift.
So we're way past just generating like a cute video of a cartoon cat wearing a tiny hat, which, by the way, was already hard enough for AI to get right.
Oh, total.
So what's the fundamental shift here? What makes it so different?
The entire mission statement is different. The core identity of Sora 2 is not the same. Classic AI applications, they aimed for text to video, right? They made content for you based on your prompt. But with generic characters, generic environment.
Right, you'd type astronaut on the moon and you'd get an astronaut, not you.
Exactly.
Yeah.
Sora 2's mission is to move way past that content creator role. It doesn't just create content for you, it literally puts you into the content.
Wow. Okay,
Yeah.
that changes the entire conversation.
Yeah.
We're moving from a simulation that's driven by a prompt to personalized, high-fidelity starring roles.
Yes.
This system is basically transforming the user.
Yeah.
You're not just the content creator anymore. You're the tellish. You're directly a part of the content itself. You're the main character. You're the digital twin.
Absolutely. Our mission today is to figure out how on earth OpenAI managed that. How did they bridge that reality gap? How did they solve the physics problem? And maybe most importantly, what safeguards did they have to build now that we have these high-fidelity digital twins running around on the virtual surface of the moon?
I am super keen to understand the tech, for sure, but I'm also really focused on the implications. Because if the tech is that good, the conversation immediately has to pivot to control. Who owns that digital you?
100%.
But before we get there, let's talk about the villain of this story.
Well,
what was the technical mess they had to defeat to even make this possible?
precisely. Let's start by looking at the old challenge. The mountain of technical frustration that all the previous AI has just kept tumbling down. So if you look at the last few years of generative video AI, the development was, it was incredibly rapid, but the limitations were just universally frustrating.
Oh, yeah.
The villain in this story, the technical hurdle that always broke the immersion. It was the sheer difficulty of creating something that felt real, complex, and crucially consistent.
Right. And I think it's easy for people to underestimate how much harder video is compared to, just generating a static image.
Okay.
It's a whole different ballgame. A picture is just one world, frozen in time. A video, especially one that's trying to be hyper-realistic, that a sequence of thousands of worlds that all have to obey the exact same rules, the exact same shadows, the exact same laws of physics.
You nailed it. And previous text-to-video systems struggled so intensely with that core problem of temporal consistency. It was the Achilles heel.
So how did they work? What was the fundamental flaw?
Well, think about how they operated. A lot of them were basically trying to generate a sequence of individual high-quality images, like a flip book.
Okay.
And then they'd try to, interpolate the motion between them. It's like trying to make a movie by taking 1,000 really excellent photographs and then asking a computer to just draw the movement in between each one.
That sounds incredibly unstable.
It was, because if you're generating each frame sort of independently, even if you feed it a little information from the frame before, you're constantly introducing tiny errors.
And those errors just build up over time. They compound.
They compound like crazy. And that's what we'd see in the final video is, that horrible glitching, the warping, or like an object just suddenly disappearing for a frame and then coming back.
That's where the physics engine just completely failed.
Completely. You might prompt a generic character to, say, pick up a coffee cup from a table. In the first few frames, it looks okay. The cup is there. The hand is approaching it.
Yeah.
But by frame 10, because of that compounding error, the cup might just spontaneously clip halfway through the table. Or the character's hand suddenly has 6 fingers. Or the liquid inside the cup decides to defy gravity and just spill sideways.
Right, the reality gap. It was massive because the AI didn't actually understand the physical rules of the world it was making.
It understood patterns. It knew what a cup looked like, what a hand looked like, but it had no concept of the underlying physics that govern how they're supposed to interact.
It's exactly like watching a video game where the physics engine has just gone on strike. Or maybe it was never coded properly in the first place.
That is the perfect analogy. And that inconsistency, that's the villain here. Let's really lean into that idea of a badly coded game. What programmers call clipping.
Yeah, where your character just walks halfway through a wall.
Or they jump and the weight of their body just feels impossibly wrong. It's too floaty or it's way too heavy. The old AI was generating a scene in 3D space, sure, but it was failing to maintain any consistency across the fourth dimension time.
So, okay, let me see if I've got this. The core technical hurdle was that older models were kind of living in a 3D latent space. They were focused on spatial detail, like what things looked like, but they struggled massively with the continuity of time.
You got it.
So the breakthrough that was needed, it had to be a true 4D latent space model, one where space and time are fundamentally unified. They're not separate problems to be solved.
Exactly. They have to be learned together.
Because you can't put my specific, recognizable, hyper-detailed self into a system that's still dealing with, my arm clipping through my body. The stakes are just too high when it's personal.
And that leads us to the 2 specific hurdles that always killed the illusion, especially when you're dealing with human interaction. The systems failed just spectacularly at generating accurate physical interactions and handling complex scene transitions.
Physical interactions are just ridiculously difficult, and they require the AI to model these complex, changing relationships between objects.
Give me an example.
Okay, so if you generate a video of a tennis ball being thrown at a pane of glass, the AI doesn't just need to draw the ball. It needs to calculate the precise trajectory, the implied gravity, the air resistance, the force of the throw,
and then
model the complex time-dependent deformation and the shatter pattern of the glass when it hits, all while maintaining perfectly consistent lighting across thousands of tiny moving shards.
It's an impossible task for the old systems. They would just approximate it. They'd guess. And the result was a ball that might slow down too fast or glass that shattered in a way that looked flat and totally unnatural.
Because the AI was just winging the physics on a frame-by-frame basis. It wasn't simulating a world. It was just guessing what the next picture should look like.
And our brains are absolute masters at detecting when physics are wrong. Even if it's subtle, it instantly breaks the spell.
Yeah, then you have the scene transitions. That was the other big one.
Oh, man. In older AI videos, if you tried to go from like a close-up to a wide shot, or have the camera pan smoothly while the action continues.
Total disaster. You get visual glitches, warping, or worst of all, the AI would just completely lose the context of the scene. It would forget what was supposed to be there.
The persistence of objects was a huge problem. The AI struggled to understand that an object still exists even when the camera's perspective changes.
So the mountain they had to climb. It wasn't just about generating prettier pictures. It was shifting from generating a sequence of individual, inconsistent snapshots to creating a moving, cohesive world with ironclad rules of gravity, momentum, and continuity.
And until they solved that, they could never, ever credibly introduce the ultimate internal identity, the user's self, into the mix. It would have been a glitchy mess.
Which is exactly why this leap to Sora 2 is so significant.
Yeah.
They didn't just iterate on the old model. It sounds like they completely redefined the foundational structure of the generated world.
They did, and that sets the stage perfectly for the quest. How did they finally make the world stable enough to cast us in it? So if the problem was this technical incoherence and inconsistency, the quest was all about achieving hyperreal integration and stabilization. The primary mission for Sora 2 was, well, it was dramatic.
How so?
They had to move beyond simple, prompt-driven video generation and start incorporating real-world elements directly into the application, the actual physics of our world, and more importantly, the actual appearance of the user.
They weren't just chasing better computer graphics anymore. They were trying to build a reliable, stable, digital self that a user could insert into these worlds. One that wouldn't, clip through the floor and suddenly have 6 fingers.
And that meant focusing very specifically on the ability to take a person's short video input, their face, their movement, their voice, and directly reflect their appearance and voice in the final video with a level of reality that just hadn't been seen before.
And this is where the technical advancements start to feel less like academic research papers and more like movie plot breakthroughs.
Totally, because they had to solve what we're calling the synchronization crisis.
The synchronization crisis. Well, I like it. So let's break it down. What was the first huge technical hurdle they cleared? You mentioned movement and physics consistency. How did they stop the digital self from having, rubber limbs?
They did this through what we'll call Advancement 1. Hyper-realistic motion and physical interactions. And this is the core breakthrough in that 4D latent modeling we were talking about. It means the AI now models time as being fundamentally intertwined with space.
Okay, time for the mandated analogy engine. Make this concrete for us.
Absolutely. Let's use sports, and let's get specific. A highly technical sport like figure skating.
Okay, I'm with you.
Think of older AI video like a very talented but completely untrained robot trying to learn a triple axel. It understands the basic commands. You tell it, jump, spin, land.
But it doesn't understand the how.
Exactly. So when it actually tries to do it, the robot completely misses its center of gravity, the torque is all wrong, and it just crashes awkwardly onto the ice. The physics feel wrong, the weight distribution is off, and the ice doesn't even react realistically to the blade.
The robot knows what a triple axle is supposed to look like in the abstract, but it has zero understanding of the complex rules of inertia and momentum that govern that action in the real world.
But Sora 2 is like watching a world-class professional athlete. The movements are fluid, the momentum is carried correctly through the entire spin, the trajectory respects gravity perfectly, and this is crucial, the environment reacts correctly.
What do you mean by that?
The weight of the body as it lands on the ice, it generates the correct amount of snow dust. The reflection on the ice is accurate. The shadows track the movement seamlessly. Sora 2 didn't just get better at drawing objects. It got way, way better at understanding the rules of motion, light, and sock body dynamics that govern our physical world.
Because it learned them all at the same time in that unified 4D space.
Precisely.
Okay, so that combination of stable physics and realistic environments is what makes the output feel cinematic and not just photorealistic. That's half the battle won. The visual world is now stable.
Huge part of it, yeah.
But that moon scene you described at the start,
Yeah.
it included something equally challenging. It had perfectly synchronized, customized dialogue delivered in the user's own voice.
And that brings us to Advancement 2, audio-visual sync. This is the really revolutionary breakthrough in synchronizing sound and lip movements. Dialogue.
Which was always the ultimate tell in older videos.
Always. It was so often like watching a badly dubbed foreign movie. The audio track would run a few frames ahead or behind the mouth movements, or the mouth shape itself just wouldn't accurately reflect the phonetic sounds being spoken.
And that lag is the ultimate immersion killer. As humans, we are like evolutionarily hyper-tuned to detect visual and auditory misalignment, especially with speech. If the mouth doesn't match the voice, we just instinctively distrust the entire video. It feels wrong.
So to explain how they fix this, we need the mandatory food analogy.
Lay it on me.
Let's imagine achieving perfect lip sync is like mixing a super complex, delicate hollandaise sauce.
Okay, a finicky sauce. I can see where this is going.
It requires a ton of ingredients, right? You've got the sequence of image frames, you've got the audio waveforms, the timing of the dialogue track, and the precise phonetic shape of the mouth that's needed for every single syllable.
A lot of moving parts.
You need all of these ingredients to blend at the exact same temperature at the exact same time with just microscopic precision. If one single element is slightly off a dropped frame, a millisecond delay in the audio, or the wrong mouth shape for a P sound,
The sauce curdles.
the sauce curdles and the illusion is instantly ruined.
So previous AI models were basically trying to stir the visual stream and the auditory stream in separate bowls and then just mash them together at the end, which is why it's so often curdled.
Precisely. Sora 2, according to the developers' research notes, found the perfect recipe. And they did it by training the model on these massive data sets of paired audiovisual streams simultaneously.
So they learned together.
They learned together. This means the model learned to map phonemes, the specific sounds of speech, directly to the necessary facial movements and lip shapes. The temporal alignment is baked into the model's fundamental structure. It's not some patch they add on later.
So when my digital twin speaks that line on the moon, the lip movements are flawless, matching my actual voice in a hyper-realistic way because the AI understood the entire sound-image relationship from the very start.
Yes.
Wow. Okay, so that combination stable physics and perfect synchronization is what makes this system able to credibly cast us in the generated scene. It really does move from a cool novelty to professional-grade output.
Which brings us to the actual mechanism for insertion, the input method. And they made it ridiculously flexible.
How so?
You can define the scene the traditional way, with a long, detailed written text prompt. Or you can just use a voice command, and Sora just handles converting that description into the final visual and auditory video.
But the real star here is the casting call, right? How did they make that leap from generating a random figure to integrating my actual likeness into the slippers on the moon?
That's the Camio feature. This is the specialized function that lets you upload a short, simple video of yourself, a quick clip, a headshot, maybe just 10 seconds of you speaking.
And that's all it needs.
That's it. That specific likeness, your digital twin, is then easily incorporated or integrated into any scene you generate. The revolutionary part is just how simple it is. We're not talking about complex 3D scanning or deep learning facial rigging or hours of rendering. It's direct, simple, one-click insertion.
So they made the process of self-casting stupid simple. It's not like a digital puppet show where I have to manually rig my own avatar.
Not at all.
It's a direct cast into whatever world I choose, with just crazy high efficiency. The technical barriers to starting in your own fantasy life have basically been eliminated for the end user.
They're gone.
And that accessibility, that's what's so vital.
Yeah.
Because it leads directly to the discovery, the realization that this isn't just a tool anymore. It's a whole new type of social creative platform.
Yeah, once they solved the physics and the synchronization problems, the whole scope of Sora 2 just exploded. It completely shifted the platform's core utility. The discovery here is that Sora 2 changes the user role, and it does it dramatically. You are not just directing the action from behind a keyboard anymore. You are, by design, directly a part of the content. You're an asset, a character, a reusable digital twin.
It's the ultimate convergence. You are the director, the writer, the key grip, and the lead actor, all rolled into a single identity file that just lives inside the app.
Exactly. And this is all facilitated through the characters feature. This means you and your friends can literally be named characters in the videos.
Oh, wow.
When you set up a scene, you don't just say a woman runs in despair. You say @Minna runs in despair. And you, as Minna, you retain the initial control over how and when your character gets used in that video.
Okay, so that's where we move from a standalone generation tool to a true social ecosystem. The moment you introduce named characters and easy casting, the product stops being just a tool. It becomes this hybrid creative platform.
Absolutely. Because Sora 2 has evolved into a full-fledged social media platform hybrid that's focused on collaborative creation. Users don't just generate content and then take it somewhere else to share. They create, they iterate, and they share videos within the app's ecosystem.
And there's an essential element here that defines this ecosystem, right? And it's what truly sets it apart.
The remix everything feature?
That's it. This is where the social dynamic starts to spiral in the best possible way.
The remix capability is the engine of this entire new creative structure. Because every video that's generated, it maintains this traceable, layered structure. It's not just a flat video file. Which means users can take someone else's creation and instantly put their own spin on it. That means swapping characters, changing the aesthetic vibe from, say, cinematic to animated, adding new scenes or extending the storyline. It's non-destructive editing, but applied socially.
Okay, so let's make that real. Let's say I create a hyper-realistic, minute-long cinematic trailer for a noir mystery, and I star my digital twin as the hard-boiled detective. You, as another user, could take that trailer, swap me out for your digital twin, change the visual style from noir to 8-bit retro gaming, and suddenly you have a completely new, yet functionally identical story structure.
Precisely. The original lighting, the camera movements, the overall rhythm of the edit, all of that stuff is preserved in the underlying layer. You're just modifying the surface assets.
That democratizes professional-level iteration. You don't need the original project files or high-end editing software. You just remix the base concept right there in the app.
It's a huge psychological shift in how we think about sharing content.
The complexity of the output combined with the simplicity of the input and the social ease of the remix. It's just astonishing. But I want to go back to that prompt example you mentioned, because it perfectly illustrates the psychological power of combining high fidelity with high absurdity.
Yes, the prompt that really encapsulates the whole Sora 2 experience. One wide shot of @Daniel and @Minia working together in a drab cubicle office, except Daniel only responds with mouse.
Oh man, I love that. The sheer dedication of compute power that's required to render a hyper-realistic, drab cubicle office, a setting we all immediately recognize and feel, and then to insert a perfectly synchronized, perfectly rendered human character who only communicates through realistic, contextually appropriate cat meows.
It's amazing.
That's not just video. That's instant, high-fidelity, absurdist comedy. And it proves the AI has successfully learned what humans actually value. Surreal humor.
And if Daniel decided he liked the drab office, but he wanted to be a robot instead, the remix feature allows a friend to just swap his character asset out while keeping the meowing dialogue premise and Minia's reactions totally intact.
It makes creation communal, dynamic, and endlessly stackable.
Yeah.
It's turning content consumption into active, immediate iteration. You're never really done with a video. You're just waiting for the next person's remix.
And to make the experience truly immersive, they solved that final layer of complexity. Cue the sound.
The audio.
Music, sound effects, and of course, the synchronized dialogue we talked about. It's all automatically included and generated to match the scene. If you asked for a video of a busy marketplace, Sora doesn't just draw the marketplace. It adds the murmur of voices, the clatter of coins, the sound of a donkey braying in the distance.
So you don't have to generate a stunning cinematic video of a rainforest and then realize you have to spend the next hour hunting for royalty-free rain sounds and bird chirps.
Nope.
The scene is fully realized, auditorily and visually, right out of the box.
Exactly. Sora handles the full auditory spectrum, making every scene complete. You prompt the scene, Sora delivers the complete immersive visual and auditory world. It's ready for viewing, and more importantly, it's ready for remixing by the next person.
What are the implications of this? A communal, high-fidelity platform, especially with our identities right at its center, they're enormous.
Which leads us straight into the necessary conversation about control.
Right.
The moment you go from generating generic content to inserting your actual likeness and voice into these highly realistic, editable videos that can be remixed by anyone, you run straight into the most critical, ethical, and philosophical question of the modern digital age. We're talking about the inherent risk of creating and distributing the similarities of other people, your digital twin, without consent.
And this is the exact reason I brought up the scary part right at the beginning. If the technology is this good and the remixing is this easy, what stops a malicious actor, or even just a prankster friend, from taking my digital clone and making it do something compromising?
Right.
Something completely out of character or just plain ridiculous. What happens when it's taken outside the bounds of the original concept I created?
That is the question. And it's the question that OpenAI, recognizing the incredibly high stakes, knew they had to solve proactively. They understood that if this platform was going to survive and gain any kind of trust, they needed an absolute ironclad ethical lifeline.
So what did they do?
Sora 2 operates on a stringent permission-based structure.
Okay, that is the most essential piece of information here. We need to unpack that thoroughly. What does permission-based structure actually mean in a technical sense? How is that different from, a traditional licensing agreement?
It's fundamentally different because it treats your likeness not just as data, but as a protected asset class within the system.
A protected asset. I like that.
When you use the Camio feature and you upload your video clip, you are performing a controlled authorization. This doesn't grant the platform blanket ownership of your face. It grants specified revocable usage rights, but only within the confines of the platform.
In traditional media, when you sign, say, a model release, you generally sign away your rights for all sorts of uses, often in perpetuity for a lump sum. This AI system sounds like it's suggesting a sort of dynamic, tokenized consent. Is that an accurate way to put it?
That's a brilliant way to phrase it. Dynamic consent. Every user maintains active control. When you upload your likeness, you can specify where and how your digital twin will be used.
So you can set rules.
You set the rules. For instance, you could allow its use in comedy remixes, but block its use in anything political or, mature content. This essentially grants the user real-time veto power over their own digital clone.
But the power dynamics of remixing complicate this. If I create a video starring my digital twin, and then you come along and remix it by swapping me out for your twin, is the permission for the original video still somehow attached to that remix?
Yes, that's where the structure gets really innovative. The permission is tied to the underlying character file, not just the single video instance.
Oh, okay.
So if you try to generate a video using a friend's likeness, the system automatically checks that friend's permission settings before it even starts to render. If the friend has restricted their likeness from that type of content, the system simply won't process it. Or it might swap them out for a generic avatar. It ensures the integrity of the permission is maintained inside the app's walled garden.
Okay, this is critical, but I have to play the skeptic for a second. This system sounds robust inside the Sora 2 application. But what happens in the real world?
What do you mean?
If I take a remix of your digital twin acting ridiculously, and I export that video file, and then I post it to TikTok or Instagram outside of the walled garden, does the Sora 2 permission structure have any teeth left? Does revoking permission still matter once the file is public?
And that's the boundary line. That's the honest answer. Once a user exports and shares content publicly on external platforms, traditional digital content laws take over. Sora 2's internal controls are nullified at that point.
So it's not a perfect shield.
It's not.
Yeah.
However, the system is designed to prevent malicious or non-consensual content from ever being created within the app in the first place, or at least content that violates the initial user's defined restrictions. The main safeguard is creation prevention rather than post-facto removal.
What's fascinating here, though, is that they recognize that if you're putting yourself, your actual identity, into the creative process, the technology must grant you control, not just over the content, but over the character file that represents you.
Yes.
And that raises a really important question for the broader AI landscape. Is this dynamic, user-centric control the minimum ethical standard for all future AI identity systems? The power has to remain decisively with the individual.
It has to. And this fundamentally sets a precedent. Your identity cannot be automatically ceded to the platform just because you generated a clip. You maintain ownership of your digital self, and the platform becomes more like a custodian of your digital twin's usage guidelines.
And this confidence and control is what allows for the creative freedom we were talking about earlier. Yeah. The ability to star in any world imaginable without users feeling perpetually exposed or vulnerable.
And those worlds, by the way, are incredibly varied. The tool creates video with what they call unprecedented realism across multiple styles. Your digital self can live in a grand cinematic masterpiece, a highly stylized animated short, a perfect photorealistic scene, or something completely surreal like our opening moon sequence.
The limits are only defined by your prompt and, crucially, by your own permission settings.
Right.
So your digital twin can seamlessly transition from running on the moon in slippers to being a claymation figure in a period drama, all while maintaining recognizable facial features and perfect voice synchronization.
Yeah. It's the ultimate flexible self-casting system, but one that respects the integrity of the user's likeness.
Now, for the current reality check, this incredible power isn't available to everyone just yet, is it?
No. For now, access to Sora 2 is currently restricted. It's only in the US and Canada, and it's via an invitation system.
a very strategic, staged rollout.
Yeah.
Which makes sense. I mean, given the immense computational power needed to run these complex 4D simulations, not to mention the sensitivity of the identity features, they're managing the technical load and the potential ethical scrutiny very carefully before a wider release.
They have to. Which brings us all the way back to the power of this tool. It doesn't just democratize filmmaking, it democratizes hyper-realistic starring roles. It makes everyone an actor in their own life stories or their fantasy lives.
Yeah.
And it does it with minimal effort and, crucially, with maximum control.
We've really moved beyond asking, what can I create with this new app, to asking, what story will I be in today, and which version of me will I allow to star in it? The digital self has truly arrived, and it demands autonomy.
So here's the final thought. If your hyper-realistic digital twin can star in any movie you write, based only on your words and your consent, what stories will you choose to tell about yourself? And which version of you, the real self or the digital self, will you decide is the most compelling reality to explore? That is the question that's going to define the next decade of creative technology and personal identity.